Okay, in this video I will be doing problems 4, 5, and 6 on the Finite Final Exam version 1. So question 4 says, a committee contains n members if the total number of subcommittee with 3 members is 56. What is n? Well, this is a very abnormal question. It wants you to understand combinations in a way that we don't usually use them. So how do I know it's combinations? Subcommittees is essentially just forming a group. Within a subcommittee, there isn't a first, second, or third, or president, vice president, speaker. They don't have specific roles. You're just making groups, and groups is exactly what we do with combinations. So that's something that I wanted to mention. But here we're told that we're choosing 3 and the answer is 56. So we don't usually do problems this way, but luckily 3 is small enough to do this. My guess is that your final will not have this type of question on it. It's kind of out of the ordinary, but it's not very hard to solve. So let's take a look at that. So here, let's take a look at what we're trying to do. We have sum n choose 3 equals 56. Well, if you look at the formula, this is what the formula would be: n factorial over n minus 3 factorial equals 3 factorial equals 56. In my opinion, this is going to be too much of a nuisance to try to solve algebraically. Here you're going to have 3 factorial is 6, so you just divide 56 by 6. And when you're dealing with factorials, it's going to be somewhat difficult to solve algebraically, unless, I mean, it's not really worth it. So honestly, the best way to solve this problem is to just make an educated guess and then kind of go from there. So I'm going to pick 6 choose 3 and just see how it ends up, because I know that this is going to be an integer, so this equals 20. 6 choose 3 is 20. Okay, well that wasn't enough. Let's go up one. 7 choose 3 is 35. That's not quite enough. 8 choose 3 is 56, and there it is. Okay, so n has to be 8 for this to work. My guess is if they ever were to repeat this question, they will still keep n to be less than 10. Since you are going to have to do this by hand, they'll keep it n less than 10. My guess is they probably won't actually repeat this question, since it's kind of out of the ordinary, but who knows. So now you at least know how to do it. Let's look at question 5. Question 5, find the maximum 2x plus 3y on the feasible set given by x is greater than or equal to 0, y is greater than or equal to 0, the line 2x plus y is greater than or equal to 2, and the line 3x plus 4y is less than or equal to 12. These are very common questions. This is something that we will have to get used to doing. The good thing about this problem, these two boundary conditions here, x is greater than or equal to 0, y is greater than or equal to 0, tells you that you're in the first quadrant. So that really makes things a lot easier. This is a very time-consuming problem, but that does make things easier, so at least you know you're in the first quadrant, the top right. Okay, let's take a look at this. So the first thing I do is I like to find the intersection point. So I'll let y equal 0 in that boundary condition, so 2x plus 0 equals 2. I can solve for x, which equals 1, which means I have the point 1, 0. Then I'm going to solve for the y-intercept. 2 times 0 plus y equals 2 implies that y equals 2, so I have the point 0, 2. Now what I do when I draw my line, I will make the point 1, 0 and 0, 2, and I'll connect those, and that's my line. Let's do it for the other boundary condition. 3x plus 4y equals 12. Well, that's going to imply that x equals 4, and that means that we have the point 4, 0. And then for the y-intercept, we have 3 times 0 plus 4y equals 12. Well, that's going to imply y equals 3. So we have the point 0, 3. So I want to connect these 2 points to make my other line. Of course, I'm in the first quadrant, so because of the first 2 boundary conditions. But now I have 2 lines that I can connect. Here's a picture of that. So here are my points. I have 0, 3 and 0, 4. I have 1, 0 and 4, 0, and you can see that I have them connected. You actually don't have to go all the way out here. If you don't want to, you just connect them right there. Since we know that we're in the first quadrant, because of those first 2 boundary conditions, the x and y are both positive. Okay, so we know that that's true. Alright. Now I need to find the direction of those lines. I'll go back just a little bit. So I don't know which side to fill in. I don't know if I'm over here, if I'm over here, if I'm in here. I have to find where I am. I know that I'm in this corner, but I don't know where, so I have to find the direction. My method that I like to use is just to plug in the origin 0, 0 and see if it works. So 2 times 0 plus 0 is 0. Is 0 greater or equal to 2? No. That's not true. So I know I'm going to have to go away from the origin. So that tells me the direction of that line. And then here for this boundary condition, I plug in the origin. 3 times 0 plus 4 times 0 is less than or equal to 12. That is true. So I want to go towards the origin for this boundary condition. Okay, so that helps me know the directions. Here, I actually have that here. So when you shade in your area, here I have all of the boundary conditions here. So it's the darkest area, and this lets me know where it is I'm looking for. And I can see my corner points must be here, 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 and here. This is the region that we're concerned with, okay? So that's not too bad. So I plug those into that objective function that we were given. So I plug in the point 0, 3, and I'll get 9. That ends up actually being the answer, but to be sure I should test all the points. 0, 2, I get 6, 1, 0, I get 2, and 4, 0, I got 8. Okay, so this was the largest. I'm looking for the maximum of this function, so thus the maximum of 2x plus 3y must be 9. So that's why the answer is 9. Okay, hopefully that helps. The next question is very similar. We're given the function negative x plus 2y, and we want to find the minimum of that function due to these boundary conditions. So the boundary conditions are x is greater than or equal to 0, x is less than or equal to 4, y is greater than or equal to 2, and the line x plus y must be greater than or equal to 4. So I'm going to do a very similar process, but I'm not guaranteed that I'm in the first quadrant, so that's different. So here I'm just plugging in, is 0 greater than or 0? That's true, so I know the direction. Is 0 less than or equal to 4? That's true. Is 0 greater than or equal to 2? That's false. Is 0 plus 0 greater than or equal to 4? That's false. So now I know the direction that I'm going. Okay. This one's a little bit easier. Here you have like, just straight lines. Let's look at our boundary conditions. So here I just do x equals 0, x equals 4, y equals 2, and then here I can find the points. This would be 4, 0, because this is x plus y equals 4. So for the intersection, you can just find x equals 4, so you have the point 4, 0. and then here you can find the point 0, 4. So that's how I connected those. So here that's this line. And we know the direction because we plugged them in. So here is our region of interest. It's up here, you can see that. And that means our corner points have to be here, here, and here. Well, this problem is easier than the previous problem we worked on. So it's easier to see which points are interest. Again, to remind you that we are looking for the minimum, there would be no maximum to this. This is just going to keep going. So here we have 0, 4, and then here, what do we have? 2, 2, and then here looks like we have 4, 2. Alright, so let's plug those points in. So I plug in 0, 4, I get negative 0 plus 2 times 4 is 8. Plug in the point 4, 2, and that's negative 4 plus 2 times 2, which ends up being the answer, which is 0. And then I plug in 2, 2, negative 2 plus 2 times 2 is just equal to 2. So this is going to be my minimum right here. So thus, the minimum of negative x plus 2y must be 0. Alright, so I hope that helped if you were struggling with those 3 problems. And on the next video, I will be dealing with 7, 8, and 9. Okay, so I hope this helps in your studying for your finite final.